Okay, so last time takagumira pa titration example. So let's continue from there. So it's an exercise that I'd want you to do. I want you to calculate the concentration of the acid given that the concentration of the base is 0.5, the volume of the base is 25 cubic centimeters. Remember to change this to what? To cubic decimeters, and we said you divide by 1000. Also need to change this, divide it by 1000, and I want you to substitute into this formula that says concentration of acid times volume of acid, all divided by number of moles of acid is equal to concentration of base times volume of base, all divided by the number of moles of the base. And then you make the concentration of the acid the subject of the formula. So I want to try kuita urwega. Can you make Ca the subject of the formula, and what do you get? So we'll see that next time tonight I meet. Okay, now let's get to this question. Name the method which is being used. So the method is what? This method is called a what? Titration, right? Titration. So that's the method that's being used there. Explain why phenolphthalein indicator is added in order to show the end point of the reaction. So it's not add indicator but it is even when to stop the titration. So I open this tap. Remember I said open this tap and you start to mix your acid and your base, but how do you know when to stop? The reaction a color indicator. So my indicators are not colors akasiyana. I see the most common indicator is universal indicator. Universal indicator to kana solution area neutral, meaning that neutralization yaitika inofana kuita color green, and inoita color red kana iri acid, inoita color blue kana purple kana iri base, as kana iri pa neutral inoita green. So it's an example we can use here. Dai wanga wakaisa inonzi yo universal indicator into this solution, then since it's a base inotanga iri blue kana purple. As you add the acid, it will start to change. Kana neutralization rate kind of a green because the color of universal indicator in a neutral solution is green. Ukadarikidza ukanonoka kustopa, your solution becomes acidic. Acid ndo inenge yawanda saka inonoita red, saka unenge uchida kutaimira kuti iite green, but green you stop. So ndo basa rema indicators anotibatsira to know when to stop. Okay, let's move on to the next question. So complete, balance and complete. So remember, kanataka what we form. We need to know these labels. Now this is a base. So my hydroxide is my base. So to mix base na acid. Ma acid, kune ma popular acids atikati munanofana kuziva. Examples are iyo sulfuric acid, tinemwe inonzi nitric acid ine formula yekuti HNO3. Inofana kuzikanwa. Kuita imwe inonzi hydrochloric acid ine formula yekuti HCl. Saka tine ma acids matatu, nitric acid, hydrochloric acid na sulfuric acid unofana kuziya. Then ma base ese ma hydroxides tikangoti metal, any metal yatatora pa periodic table tikati metal mberi kwacho toti hydroxide yato base hydroxide. Saka tikuti sodium hydroxide, calcium hydroxide, potassium hydroxide ese ma bases. Then tine rimwe special class rema base anonzi ma carbonates. So metal carbonate, carbonate. So my metal carbonates ese ma bases. Examples, the most popular is calcium carbonate, calcium carbonate, sakatakat calcium carbonate, sodium carbonate, lithium carbonate. All those are bases. Asima carbonates aya tofana zoti kama mixa tatima base, so kama mixa ne acid yato neutralization andile. Saka base redu kana ri carbonate, base redu kana ri carbonate, kat carbonate plus acid tino form what? A salt plus water takuzoti plus carbon dioxide, panozobuda carbon dioxide. So difference here inofana kuzikanwa. If the base is a carbonate, we form salt, water, and carbon dioxide. But kana yakadai tina acid and the base, which is a hydroxide, we simply form our what? Salt and water. But my reactions say whether you use a carbonate or a hydroxide, is my neutralization reactions. Sapanamba kunzi complete and balance. Saka tidu to unyore salt and water, to tinyore salt yacho inoform ipapo. The salt that is formed there. What is the name of the salt that's formed there? So salt here do tinoiform say tinoyapa napa tinotora metal iri kubva ku base. So chaona kuti base rako ndo rinenge rine metal all the time. Saka unotora metal from the base. Wobva watora kuno ku sulfuric acid unotora nonzi sulfate ion. So let's write the sulfate ion here. So sulfuric acid will give you the sulfate ion, which is SO4, SO with a small 4, a charge of 2 minus. SO4 has a charge of 2 minus. Then iri hydrochloric acid inokupa the chlorine minus ion. Then iri nitric acid inokupa nitrate ion, which is NO3, rine charge of minus 1. Sanda utubate kuti iri charge of 2 minus, chlorine in a charge of minus 1, or 1 minus in a charge foot of minus 1, or 1 minus, however I want to say it. Saka charge in a basa because we not basa to balance. So you go to your periodic table when you're forming the salt. Wono chaka kuti metal yacho iri group chi. So the question to ask is what group is the metal? And it is saka periodic table kwa tuona kuti sodium iri group 1. Saka inoita a charge of +1. Saka sodium inenge in charge of +1. Tukuti this charge of +1 iri pa sodium iri kunobatana ne this, we call it an anion. This one is an anion because it's a negative charge, anion negative charge, anion negative charge. So when you have a negative charge, it's called an anion. When you have a positive charge, it's called a cation. So tukuti susuziva futi kuti what? Metals are the cations, whilst non-metals are the what? Are the anions or negatively charged, so any negative charge I had done a positive charge, right? Then is ziva futi nyaya takataura yema groups here kuti metals are found where per periodic table groups 1 kusvika 3, whilst non-metals are found where? So metals are found groups 4 kunosvika ku group 8. Saka ukanzi tsvaga metal, just go and look for groups 1 to 3, and non-metal unoenda groups 4 to 8. Saka zvora SIR between groups 1 and 3 anoita ma-cations, aya anoita ma-anions. So tikuti isusu kune mamwe ma-anions, ma-special anions akaita sana sulfate, iri nonzi sulfate. Well, let's name them as well. Sulfate, this one is called the what? Chloride. Chloride. This one is called the nitrate. The other one is called the nitrate. Anofana kuzikana nomasta sulfate, chloride, nitrate. Ndeka rimweo anion ratofana kuzandero re hydroxide, the OH minus, or capital letter O and H with a negative charge. Iri rinonzi hydroxide. No start hydroxide. It's also a special anion pamuna kuziva iroro. Saka tina hydroxide, sulfate, chloride na nitrate. Unofana mazane ma charges aro rinotsa tinani -1. Saka tine -1 SI1 2 3 -1 irne -2 or 2 minus. All right, so I think we have explored background yazo. Saka salt tada kuchigadzira sei hande ku base. So what group is the metal in our base? So because it's always coming from the base, and what group is the metal in the base? Base ndo supply metal wako. So unofanira kuziva kuti ndo zvaunofana kuenda otsvaga base rako kuti ne metal ipi. Base redu ne metal inonzi sodium iri mu group 1, saka inoita charge of +1, andika Why is this so? You must also remember that charge